Viktoriya and I's mechanism was the acid catalyzed dehydration of an alcohol. So this reaction is a very common method for making alkenes. Some facts about it: the equilibrium constant for this reaction is small, and the reverse reaction, the hydration of alkenes, is a much larger equilibrium constant. So to counteract this, the reaction is forced to completion by removing the products as they form. Concentrated sulfuric acid or phosphoric acid are commonly used reagents for this reaction. These acid catalysts transform the OH group, which is normally a poor leaving group, into H2O, which is a very good leaving group. And overall, this reaction resembles an E1 mechanism.
So in the first step, the acidic proton is abstracted by the oxygen that is acting as a nucleophile, and this protonates the alcohol, giving the oxygen a positive charge. So let's take a look at what that looks like. Here you can see the arrows showing how the acidic proton is abstracted by this oxygen, and then this bond over here forms a negative charge on the conjugate base that is also formed.
So now that the OH group has been protonated by the strong acid, it can now leave as H2O as the good leaving group. And the oxygen in the H2O takes the electrons from the sigma bond of the oxygen and carbon here. And that makes it so that the H2O can leave as a neutral molecule, and there's a carbocation left on this carbon. So we can look the arrows here. We see these electrons moving to the oxygen, so it can leave as water. And we have the carbocation left right here. And this step is the slow step of the reaction, the formation of the carbocation, and therefore it is rate limiting for the reaction.
Finally, in the last step, the oxygen in H2O acts as a nucleophile in order to deprotonate and form the alkene. So if we look here, we can see the oxygen right here acting as a nucleophile and grabbing this hydrogen, and this bond over here is the one that forms the alkene, and then we also form H3O+.
So some pros and cons to this reaction. This does not use any particularly harmful reagents or produce dangerous byproducts. One possible con for this reaction is, again, as we mentioned earlier, that the equilibrium constant is small, but this can be counteracted by removing the low boiling alkene to maximize the yield.
And finally, we have a few practice problems, so feel free to pause and see if you can come up with the products and draw the mechanism. And here are the references that we used.